A linear combination of vectors is when you have two vectors, like I have here, and you multiply one of the vectors by something, let's say 2u, and you add it to like 3v. Anytime you do something like that, you're creating what's called a linear combination. In this case, I can actually work out what that equals. 2u is the same thing as 414. 3v is the same thing as 15.3. And when I add them together, I get 1917. So 1917 can be written as a linear combination of the vectors u and v. A somewhat complicated question is there a way to take the vectors 2, 7, and v is 5, 1, and if I put these onto a grid, they might look like that. And if I add them together, I end up with the resultant, something like this. But if I were to multiply and get 2u instead, well, now I'd have a different resultant. Maybe it would look like that. Well, the question is, can I somehow get vector 3126 as a linear combination of these other two? In other words, is there an a and a b so that au plus bv is equal to 31, 26? So 3126 is maybe some big, vector over there. Is there some number of these, maybe fractional, or some number of these that somehow together creates that? And the answer is yes, there always is a way to do that, and here's how it works. 2, 7 plus b, my unknown, 5, 1. We want those together to become 31, 26. Well, if I distribute this a through, I get 2a, 7a. If I distribute the b through on the second vector, I get 5b plus 1b equals 31, 26. Then I could add these two vectors together by putting their x components together. 2a plus 5b, comma, 7a plus b equals 31, 26. Well, this is going to turn into a system of equations because I want 2a plus 5b to equal 31 and 7a plus b to equal 26. So we write down that system of equations. And I'll multiply this bottom equation by negative 5 minus 35a minus 5b equals negative 130. Then I'll add these two equations together and get negative 33a equals negative 99, or a equals 3. Plug that 3 into this top equation. 2a plus 5b equals 31, 6 plus 5b equals 31, 5b equals 25, b equals 5. So the answers are a and b are 3 and 5. So this means if I take this u vector over here and I make 3 of them, and then I take this v vector and make 5 of those, the resultant diagonal of that big parallelogram will be the goal of 31, 26. And that's called rewriting a vector as a linear combination of two other vectors. And it's, unless sometimes, like if the two vectors are parallel or something, if these two are parallel, it may not be possible, or it's not possible. But as long as these two vectors are not parallel, it's always possible to get any vector that you want. Sometimes it involves a and b being negative.